Now let's take a few minutes to look at some algorithms for multiplying 2, 3, 4, however many digit numbers. So more than our basic multiplication facts. I'm going to start with what's called the standard algorithm. This is what most students would use when multiplying, but definitely not all. Lattice is very popular. Every semester I have students who use the lattice as their main form of multiplication. For me personally, my middle schooler was having a hard time when he was learning multiplication with the standard algorithm, but the lattice made a lot more sense to him. So he still uses lattice now to multiply these 2, 3 digit numbers. The standard algorithm, the problem is a lot of what we do, we just kind of say and it's hard to see. And that works fine for, like I said, a whole bunch of people. And this is what the majority of students would be used to seeing, and the parents of students would be used to seeing, but it definitely doesn't work for everyone. So we start with that 2 that's in the ones place, and we're going to multiply 2 times 5, and that's going to give me 10. And I have to carry that 1 and then put the 0 down below. Now I'm going to keep with that 2 in the ones place, but I'm going to multiply 2 times 3 and add the 1. So 2 times 3 is 6, plus 1 is 7. I'm done with that 2, and I'm also done with that 1 up top. I've already used it. So I'm going to move on, and I'm going to use the 1 that's in the tens place. Now, since the 1's in the tens place, our answer is going to start in the tens place. You can either leave that 1's place next to it blank, or you could have put a 0 there. Your choice, doesn't really matter. That 1 times 5 is going to give me 5. Again, it's got to go in that 10 spot because the 1 is in the 10 spot. That's really 10 times 5, which is 50. And then 1 times 3 is 3. It's going to go over there in that 100 spot because technically that's 10 times 30, which is 300. All right, then I'm going to add these up. So 0 and 0 is 0. 7 plus 5 is 12, and 3 plus 1 is 4. So I get 420. So like I said, the standard algorithm is probably the most popular, but the issue is a whole bunch of what I said, the work I did, I only said it, I didn't show it. So that can be a lot of steps that we have to internalize. We do have some other options if we want to show more of those steps. So I'll keep the same problem so you can compare it with partial. Partial is going to start that same way, 2 times 5, but now instead of regrouping, I can just write 10. I'm still going to keep with that 2. 2 times that 3 stands for 30. Remember, we can think about the expanded form. This is 30 plus 5. So when I'm multiplying 2 times 30, that's going to give me 60. We also can visually see it because the 3 is in the 10 spot, so that 6 is going to go in the 10 spot. Now I'm going to multiply the 1. Remember that 1 is a 10. That 12 is 10 plus 2. So that 1 times 5 is going to give me 50. I'm going to put it in that 10 spot because it's really 10 times 5. And then 1 times 3, that's really 10 times 30, is going to give me 300. Now I can add these guys up. I'm going to get a 0 in the 1 spot. 1 plus 6 is 7, plus 5 is 12. And I get 420. So partial is very similar to standard, but you don't have to regroup. You can write your entire part of your answer down below. Last, let's look at lattice. And I'm just going to keep the same problem so we can compare. With lattice, I should write the problem up here, over here to the side. With lattice, this would work for any amount of digits. 2 by 3, 2 by 4, 5 by 5, doesn't really matter. But I am going to make a grid that is 2 by 2. 2 digits for one number and 2 digits for another number. Does it matter really where you put the numbers? I'll put the 35 at top. You could have put the 12 there. But you have to put 1 going across and 1 going up and down. We've seen a lattice with the addition. This one's similar. It's not exactly the same thing because there's not addition. But lattice refers to like a patterning, like in a fence. We have these diagonals, so I'm going to come through each box and I'm going to put a diagonal. There we go. And now I can do my multiplication. This first box right here in that top corner is going to be a 1 times 5. That gives me 5. If you want to put a 0 up top, you can. You don't have to. I'll come down here and do, actually, well, I'll keep up. I'll do this box that's on the top row to the left. That's going to be 1 times 3. That gives me 3. Again, if you don't want the 0, that's fine, but the 3 does have to go down below, like the bottom part of the box. Then I'll come multiply the 2. 5 times 2 gives me 10, and 3 times 2 gives me 6. Now I'm going to take these diagonals, and I'm going to add every number that's in between those diagonals. So the bottom diagonal is just 0. Next, in the diagonal, I have 3 different numbers. I've got a 6, a 1, and a 5. So 5 plus 1 is 6, plus 6 is 12. So I do have to carry. In the next diagonal, I've got 0, 3, 0, and 1. So that gives me 4. So I get my answer of 420. Feel free to rewatch that as much as you want to. You also can go to YouTube and type in lattice multiplication, and you'll get tons of different hits for this that give you more examples. So there's plenty of those out there. There are actually other multiplication techniques as well. These just are the 3 most commonly used right now. These multiplication algorithms go kind of in and out of style. There's nothing new about them. A lot of times people call it new math. They've been around forever. They've been around for a really, really long time. And we've been multiplying as a human civilization for a really long time. And they're all forms of different types of multiplication. One is not better than the other, but students are different. So students are going to need different tools. So each one of these would be commonly used to teach students, and then they could choose which works best for them and continue to use that one throughout their career.